Hello and welcome to Build Your Own CPU Part 8. In this episode we'll be covering the general layout of the instruction decoder and how the signal paths operate through the circuitry. These are the demultiplexer boards fitted onto the instruction decoder. First one here is the card select demultiplexer. We'll have it connected to D6 and D7, coming across into the demultiplexing section. The card select on this one is just linked to 5 volts, so it's on all the time. And these links here are set so it's doing a card demultiplex. Basically the outputs from here gets fed around onto this bus that feeds down. When 6 and 7 are both on, we get this output on. When 6 is on and 7's off, we get that one. And when 7's on, 6 is off, we have this one. And when they're both off, we get this one. So you get 1, 2, 3, 4 card selects that feed down to the next boards. Now the next one down, this will be the destination addressing mode decoder. So we want bits 0 and 1. And again, this doesn't use the card selects, it's just on all the time. So we'll link the card select to positive supply and they decode. And this is where I made the mistake on the board. This row of pins should have been up the other way. But it should have been just links going across. But sort of a bodge around it. I can link across like this from above, otherwise I'll actually made a new board. Well, these addressing modes, they feed out onto the first 4 runs here. They go down onto the first group of 4, which we know will be the wrong ones, but they'll all get shuffled over as we move along. Now, the next one down, that'll be the destination decoder. So we're on bits 2 and 3. Again, card select is just directly on. So they're decoding all the time. And again, I've had to do the bodge wires. Now, up here, you can see the source has come down. Has moved across 1 and gone down here. Now the destination, or source 2, has gone onto the first row group. If we move down another board, this is the first of the actual instruction decoder demultiplexers. So we're on bits 4 and 5. Each of these next 4 boards will all be on bits 4 and 5, and we just use the demultiplexing of 6 and 7 to select which card it will be. So in this instance, it will be 0, 0 on 6 and 7 from the card select. So we're on this card select here, which feeds into the card select input there and turns all these on. And again, the bodge wires. This again feeds out onto the first 4 going out, but the 8 up here have all shifted over 4 again. Now we come down to the next instruction. It's doing the same, except we're on a different card selects this time, and it feeds onto the first 4. And these 12 have all been moved across. You go down to the one below that. This is where the actual instructions feeding in. It feeds up and down the bus over this side to feed all the cards. Again, it's on 4 and 5. We're on the next card select over and signals across. Ones here have all been moved over 4 places, and these ones join on the end. Then when we get to the last one, the signals are being fed down this time instead of up. So again, it's on 4 and 5. We're on the last card select there. Does the decode, feeds across in the first 4, and all this lot all feed across onto the right over here. Now these ones here are identical to these here. These are ones that are actually feeding out onto the next part of the decoder. These ones here just feed this LED board at the bottom, so you can see what's going on. So this is these first 4 are the source addressing mode. The next 4 are the destination addressing mode, and these ones is what instruction it is. Now we're going around a loop at the moment, so it's just doing 3. Let's see if I can press a key and make it do something else. So there we go. You get different ones coming on in a different part of the program. Here we have the motherboard generating the T states and the pulse signal. They're all coming out the bottom down here, and they're feeding down this blue card. It's blue for bus, comes across there, and then it feeds into the start of the instruction decoder. It just feeds straight across these wire links, and across all the way across here over to this row of cards. This is the first card in the demultiplex in the matrix. We've got the T states feed across here onto this board. We come further up. We've got all the instructions and source and destination addressing modes feed onto this grid here. It's just a great big bus that feeds all the way at the top. And then the actual decoder cards, they tap off wherever they need it, going across here, whatever signals they want. There's I think it's 72 different signals going across in all. So let's turn that light off. So that's one big bus going all the way down. This is the beginning of the main part of the instruction decoder. This board is the T0, T1 and T12 state decoder. If we look just at this bottom bit here, don't take any notice of these numbers here, that's just a pin number. You've got T0 coming in on this one here, and that's got two inverters. It just acts as a buffer to reduce the amount of loading on the rest of the circuit. And this one is T1, which has got the same thing on it. Now these go out to multiple outputs. You can see there's T0, then T1, T0, T1 as each instruction goes through. Now these do actually feed out to all these different signals, but the rest of the board further on is designed in such a way that we don't actually need these. I could use that just for testing, but they're all actually joined together. I've slowed it down a bit so you can see one's going each time. If I speed it up again, they look like they're going together. They're not. And you can see how when the T12 instruction comes, the different outputs it puts on. We'll go through the logic in detail at a later time. Now the next board down, I'll get that in shot. Turn that light off. Now this is one of the T14 cards. T14 is the most complicated step. It's the one where all the action happens. So it's picking off on the left here all the different signals from what instructions coming in. It'll be picking off the T state. There'll only be one of those, as in T14, and addressing modes, etc. Lots of ANDs and OR gates, and again here's all the different possible control signals going out onto the next matrix. And the next board down, that's another. It's T14 as well. There's lots of logic on T state 14 because of to say each instruction and mode works slightly different. And you may notice there's a couple of diodes here on the board above. I had the resistor on. That's where I made a few mistakes and had to basically rewire things. Now these two boards are all to do with the addressing modes. So this is T2, T3, T4, T5, T8, T9, T10 and T11. Now this top board up here is just dealing with T2, 3, 4 and 5. So there's not many signals coming out here at the moment. We must be just using addressing mode on the others. And again, there's spare bits on here, but there's only like 4 actual signals that we need out of here because some of these can be added together because they're always on together. And then on the bottom one, this is the destination or source 2 addressing modes, and that's obviously being used in whatever part of the sequence we're in. And it's identical board to that one, except we just feed it with the destination addressing mode and T8, 9, 10 and 11. So they're quite simple boards, those. As I mentioned earlier, it just makes it easier to split off the addressing mode from the actual instruction. And then below that, that's the T6. So whenever we come in and we're doing a T6, that's basically a fetch into the B register. Again, we've got a T6 coming in here and a few other bits pieces. You see I made a mistake there and I'll put a link in to correct it. So to say this is just a prototype. The same sort of thing, and these all feed out onto the cards to the side. Now the T6 board feeds out onto this first row here and feeds upwards. There's going to be 5 buses running up here, but they all feed out to the same thing in the end. But there's 10 on each, so T6 can have up to 10 things on this bus. They feed up. The next board up, you've only got 8, but they're all on the second group here, so there's 8 of them there. And these all feed up to the next row. And if we look at the next card up, you see there's a whole bunch coming across. They're all on the third row. And there's a link here that allows me to do another bodge because I made a mistake. It's basically joining 2 rows together because there was a spare one. And these are starting to get picked off into what's going to be called the OR gates. I'll move across a bit, you can see that. That's what I call an OR. This is the OR bus matrix. And these are all OR gates because you end up with 72 different inputs to it, but there aren't 72 controls. There's only 32 because the decoder will say open, say, register A's input, and it'll do that in several different places. So if I OR them all together, I'll end up with just one control signal that goes onto the register A enable input pin. But these are just all OR gates, and these links here is allowing me to have a slight different configuration on the board. There's only got one board that does all 3 combinations. And here's your actual control signals going out on these LEDs down the side here onto another bus. Well, the main control bus this card is. We go up again. This is another part of the matrix. Oh, where are we? Gone too far? No, we haven't gone too far. This is another part of the matrix, so all the signals are gradually coming up from the T cards, and some of them are going down because they need to feed this board down here from up the top. So you've got groups 1, 2, 3, 4, and 5. This board is feeds onto this group. As you can see from this row of pins here coming in, all quite tight on these links. A lot of links on this board, on this CPU. And the top one. Turn that light off so we can see what we're doing. Again, the same sort of thing. These are all coming across from the T1, T0 and T12 board. They're going onto this further bus that feeds down to the others. So this is just another big matrix of signals. Well, they feed across. We saw the first one, OR gates. Second one's OR gates the same, and the next one up is all OR gates the same. Now they're all in together, so we end up with 32 different signals going out. This is the bottom card of the control bus. This is where the bottom decoder card feeds in. And these ones all feed onto the far side here. There's going to be 32 signals going up here. But on this side, we've also got a data bus, and then there's an auxiliary bus here. The auxiliary bus was designed in case I forgot anything, I could add it on, which there was a couple of signals to go on there. So the supply comes in at the bottom, goes through a diode so I don't blow anything up. Apart from when I put 40 volts on it, and I did blow it up. I blew the motherboard up because that's only 5 volts. But the rest of it, seeing as the MOSFETs can take higher voltage than that, luckily they all survived. So that protects against polarity incorrects, but it doesn't stop you putting too much volts in. It should only be 5.6 volts there at the most. Now at the bottom here, the whole idea of this is I've got a row of resistors along the bottom. These are to clamp the bus down. And there's a little story about that I'll go into when I show you the next device I built to help test this. I've also put a row of pins here so I can connect on and measure the control signals quite easily. So I built a logic analyzer to put on that saved me a lot of trouble and allowed me to debug all sorts of things a lot faster. So this OR gate fills onto this part of the bus. Up to the next one. All these OR gates feed onto this part of the bus, and at the top these all feed onto this next part of the bus. So you've got all 32 control signals running along here. All the data lines here, as I say, the data just comes down here so I can test it at the bottom, and it has the terminating resistors on it. There's the auxiliary bus that's got like the reset signal and the carry from the adder on it, which is used further round, and there's a few spares. At the top up here, which you can just see it, these are just, that's the data bus, the data going down the data bus. And that's the internal data bus as opposed to the external data bus. And here is these other auxiliary signals. If I put my finger on there, I can actually make them turn on and off. The ones that are not being used, they're just floating, but the LEDs are there already. They actually switch in case I use them later. I think that's enough for this episode. So don't forget to like and subscribe, and I hope to see you in part 9.